Donald Trump says he wants to make the United States the capital of crypto. That sounds like support, but in practice, it changes everything. His remark triggers a global race for regulation, setting standards most crypto projects will never meet. Crypto is leaving the Wild West. A few networks will enter the regulated financial system, and many will disappear. So the real question is simple: which coins will survive, and which will go to zero? Let's break it down. No buzzwords, no speculation, just engineering logic. We'll run each project through three filters: tech, legislation, and price move potential. That separates infrastructure from imitation and engineering from marketing. These are the criteria institutions already use, and retail traders often ignore. Because in the next cycle, price won't follow hype. It will follow compliance, scale, and real world demand. The embarrassing level of content on crypto YouTube pushed me to create Crypto Holistic. It's hard to grow when the material you watch is just people reading tweets out loud, parroting whatever's trending that day. No depth, no progress, no curiosity. The same mantras repeated for years, with logical fallacies, or just blatant shilling for money. This is Crypto Holistic, a channel where an engineer shares clear, structured insights into markets, technology, and investor psychology. No influencer noise, no copy paste narratives, just clean analysis with engineering precision. This content is for educational purposes only. It's not financial advice. I believe that in the next bull market, technology will be one of the key factors influencing price. To understand my reasoning, you need a basic grasp of the underlying technology. This won't be a deep dive, just the minimum you need to follow the logic. Cryptocurrencies exist on distributed ledger technology. And yes, a distributed ledger can exist without a cryptocurrency. But only a few cryptocurrencies actually enhance their ledgers, making them more robust and enabling functions that wouldn't be possible otherwise. Out of the 17,000 tokens listed on CoinGecko, maybe a few dozen have any real application or purpose. The rest? They're like monopoly money. They might have a dog or a frog on them, but they could just as easily be replaced by anything. And yet, the technology that enables this nonsense is truly powerful. It should not be ignored by anyone planning to live longer than another year or two. A distributed ledger is a system where data isn't stored by a single party, like a bank, a company, or a government, but across many independent machines simultaneously. The consequences? No one can alter the record. No one can reverse a transaction. No one can quietly rewrite history. So, how is that different from what we have today? In most systems we use, whether we're signing a contract, buying a house, or just checking our bank balance, we rely on someone being honest: a notary, a counterparty, a lawyer, or a centralized database. In a distributed ledger, that trust is replaced by math, more specifically, cryptography, which means the data is cryptographically secured. That's what cryptocurrency actually means: a cryptographically secured currency, not something hidden or anonymous. And that unlocks something we've never had before: a financial system where you can invest in Africa or South America or anywhere in the world without worrying whether the person on the other side is honest. A system where you can lend money to someone you've never met and not fear they'll just disappear with it. This isn't just an upgrade, it's a new layer of the internet, one that changes how trust, ownership, and value move across the world. And we still don't fully understand where that leads. Just like in the early days of the internet, we couldn't imagine calling a taxi in a foreign city, driven by a stranger, speaking a different language, and feeling completely fine with it. This new infrastructure will create use cases we haven't even imagined yet. But can every distributed ledger do that? Is every cryptocurrency equally valuable? The answer is no, and here's why. There are two basic types of crypto assets: coins and tokens. Coins run on their own native infrastructure. They're the fuel that powers their blockchain. Tokens, on the other hand, use someone else's network. They live on borrowed infrastructure, like Ethereum's or Solana's infrastructure. Most tokens have no real utility. They're like monopoly money, and in many cases, the game board doesn't even exist. Still, there are a few tokens with actual use cases, like Chainlink for oracles, Uniswap for DEX liquidity, or USDC for stable transactions. Now back to coins. Coins are supposed to act like blood in a living system, but not all blockchains are alive. Some are failed forks, some are abandoned. Some are technically functioning, but have no users, no developers, and no purpose. Even among the active blockchains, not all support smart contracts, which means their potential is extremely limited. For example, Bitcoin, Litecoin, or Dogecoin have little to no programmability. What remains is a small group of cryptocurrencies built on different technologies, with different goals, each claiming a role in the next financial era. But here's the problem. Most of them still fail to meet the requirements of security, performance, compliance, or usability. And that's where my list begins. Among distributed ledgers, we can identify three main architectures: blockchains, directed acyclic graphs, also known as DAGs, and hybrid models that combine elements of both. DAGs are much less common. The most notable examples are Hedera Hashgraph, also known as HBAR, and IOTA. Their most interesting property? They're not blockchains. And that means they avoid some of the structural issues most blockchains still struggle with. Let's unpack that. No hard forks. A hard fork is when the protocol splits into two incompatible versions, and the network itself splits in half. Think of Ethereum and Ethereum Classic. Same origin, but two different chains and two different assets. This kind of split fragments infrastructure, liquidity, and developer attention. It's rarely seen as a positive. DAGs like Hedera don't allow this kind of divergence. The network has a single path forward, by design. No soft forks. A soft fork is an update that introduces new rules. Those who accept it can use new features. Those who don't can still operate under the old rules, but only partially. This creates fragmentation, not in the chain, but in capability. Some users stay behind, others move ahead. In DAGs like Hedera, there's no such split. Updates apply uniformly. Either the whole network moves forward if it's or nothing does. No microforks. By microforks, I mean a subtle but serious problem. When two nodes temporarily disagree on the order of transactions, and for a few seconds, two parallel versions of the ledger exist. In most blockchains, that's considered normal. It's part of the process. But in systems that deal with real-world tokenized assets, this can be a disaster. Imagine the same equity token, representing a share in a company, being sold at the exact same moment to two different buyers on two separate forks. That kind of inconsistency is unacceptable in regulated markets. DAGs like Hedera have finality built into their consensus. Once a transaction is confirmed, it's final. There are no alternate histories, no clones, or at least no impact. Finally, let's talk about clones. A clone is when someone takes the open source code of a project and spins up their own version. This happens a lot in blockchain. It's not inherently bad. In fact, open code is a feature, not a bug. It allows developers to evaluate the architecture, test improvements, or build competitors. But here's the key point. A good ledger doesn't fear clones, because the real value lies in the infrastructure, the developer ecosystem, and the user base. Forks, clones, or code copies don't matter much if everyone, from users to validators to institutions, sticks with the original. So what is a distributed ledger, really? At its core, a distributed ledger is code, the logic that defines what's allowed. Infrastructure, the nodes, the hardware, the cloud partners, developers who build apps and integrations, and end users who give it purpose and liquidity. When these four elements align, you have a system that can evolve without breaking itself, adapt without fragmenting, and scale without introducing chaos. That's why some blockchains, like Algorand, have also eliminated hard forks and microforks. And even if they do allow soft forks, those changes don't harm stability or trust. Ultimately, hard forks are the most damaging because they split the infrastructure itself. That's why serious investors and institutions avoid protocols that hard fork frequently. Blockchains aren't all the same, especially when it comes to how they handle smart contracts. And a smart contract, as we've said before, is just a kind of agreement, a rule-based system that can automate trust. Let's bring that to life with an example. Imagine you're buying real estate in Poland, but you live in the US. You don't know Polish law. You don't know the sellers. You don't know the process. Let's say the house has four co-owners who inherited it. They each hold a different share. There's still a mortgage to pay off. And your own financial situation isn't exactly straightforward. You don't have a stable income, but you do have a large amount of investment-grade gold, bought years ago and held for the long term. Now imagine a digital contract that can handle all of this. A bank agrees to give you a loan, using your gold as collateral. That gold doesn't leave your possession, but it's locked in the system. If you repay on time, the contract gradually unlocks pieces of that gold. If you miss a deadline, it automatically sells just enough to cover the payment. And if the price of gold suddenly crashes, the contract might liquidate everything, but only if that was in the agreement. It protects you too. The first installment of your payment goes into escrow. Then the bank's funds are used to fully pay off the old mortgage. Only after the title is clean do the four sellers get their share, split according to ownership, with taxes deducted automatically. The legal paperwork, also handled by the system, and sent to the right public offices. This is what smart contracts could do, not in theory, but in actual working systems. Of course, this kind of automation requires powerful digital infrastructure, and it needs to be simple and secure enough for institutions to trust it. That's where things get interesting. Some blockchain systems are built in a way that makes these smart contracts simple and safe. Others are more complicated. One key technology behind direct, secure transactions is called atomic swap. It's a way to exchange one asset for another, like gold for real estate, in a single, indivisible operation. No intermediaries, no I owe us, no extra tokens, just value for value. Now compare that to what's common in crypto today: wrapped assets. Wrapped assets are not the thing itself. They're tokens that represent something else, a placeholder. You don't trade real gold. You trade a note that says, this equals gold. It adds layers, it adds risk, and it creates delays, because behind the scenes, someone still has to do the real transaction. Now imagine more complexity, extra layers called layer 2s. These are secondary systems built on top of the main blockchain. Logic starts on one layer, passes through a bridge, and finishes on another. The result is a mess, hard to secure, hard to audit, and hard to scale. That's why it matters how a blockchain is designed at its core. Let's look at three major networks, not as fans or critics, but as engineers. Ethereum is the most well-known, but it relies heavily on these secondary layers. It uses bridges, wrapped assets, and complex architecture. It's powerful, but fragile. Solana tries to keep everything on one layer. It's fast, extremely fast, and efficient at handling large volumes. But it has a weakness called probabilistic finality. That means transactions are considered final, most of the time. In practice, that can lead to temporary splits, two versions of reality. And in regulated markets, that's unacceptable. Solana has also experienced several full outages in the past, another red flag. Algorand, in contrast, keeps things simple: no bridges, no extra layers. Every transaction is final in a few seconds. It uses native mechanisms for asset exchange, without wrapping or bridging, and the system has never gone offline, not once, since its launch. It's easier to program too. Developers can use a Python-like language to build applications. It's not the most popular option, but it's reliable. And that's the point. Simplicity, finality, and security. These aren't just technical buzzwords. They determine whether smart contracts like the one we imagine can actually run in the real world, with real assets and real institutions watching. That's why infrastructure matters. That's why clarity beats complexity. And that's why, when you strip away the hype, Algorand often comes out ahead. You can pause the video here and take a look at the comparison table. It shows my estimated scores across key technical dimensions. When you study the numbers, the picture becomes clear. Algorand comes out ahead in security, simplicity, and structural integrity, far ahead of Ethereum, and in some areas, ahead of Solana too. That difference isn't just academic. It should be a strong signal to any investor. What is decentralization, and why does it matter? Decentralization means no single party controls the network. No single company, no single server, and no single government. Instead, control is distributed among many participants: validators, nodes, or consensus members, depending on the architecture. And this is not just a philosophical preference. In the United States, decentralization has now become law. Under the Clarity for Payment Stablecoins Act and related bills like FIT21, the level of decentralization will decide whether a token is treated as a commodity or a security. Why does that matter? Because the difference between a commodity and a security determines how and where that token can legally operate. Securities require strict disclosures. They can't be freely traded on regular crypto exchanges. They face heavy regulatory oversight, and in many cases they become effectively unusable outside of specialized environments. Commodities, on the other hand, are much more flexible. Think Bitcoin. No single entity controls it, so it qualifies as a commodity and can be freely traded worldwide. Now here's the catch. Many crypto projects today are not decentralized enough. Their validators are few. Their governance is closed. Their funding depends on foundations or private token reserves. And if the SEC or other regulators decide these tokens behave like companies, with leaders, promises, and central decision making, they might be classified as securities. This will directly affect their price, their liquidity, and their adoption, regardless of how brilliant the tech is. So we looked at the real-world decentralization of popular distributed ledgers. And once again, Algorand stands out. You might think I'm biased. Maybe I'm just picking the categories where Algorand looks best. But maybe there's another explanation. Maybe Silvio Macaulay, a Turing Award winner and cryptographer, designed Algorand from the start to be a government-grade blockchain, not just scalable and secure, but compliant by design. While other blockchains tried to bend the rules, Algorand was quietly building something that fits them. And in a world of increasing regulation, that might turn out to be the smarter long-term strategy. Decentralization is not a fixed trait. Some networks are born open, others start centralized and gradually evolve. But decentralization can also regress. So here's the practical question. Can these blockchains become more decentralized, or are they structurally stuck? Let's look at a few examples. Solana could open up, but its architecture depends on expensive hardware, which limits who can run a validator. Unless that changes, decentralization may stay out of reach. The risk? High. Ethereum has made real progress, but still depends on concentrated validators. It could improve through more diverse staking pools and better DAO governance. Risk? Medium. Sui and Aptos are new chains, but heavily backed by venture capital. Core developers still hold most control. To decentralize, they'd need to give up real power, which is politically difficult. Risk? High. HBAR is governed by a council of corporations. Opening validator access and reducing council dominance could help, but it would require structural reform. Risk? Medium. Then we have blockchains like Ton, tightly linked to external entities like Telegram. That makes decentralization not just a technical issue, but also a legal challenge. Others, like BNB or Hex, were never meant to decentralize. BNB is run by Binance, which controls both the chain and the token. Hex is centralized economically. Its tokenomics don't allow real open participation. For them, the door may already be closed. And then there's Algorand, already permissionless, no downtime in its history, and a growing validator set. Here, nothing needs to change. Risk of re-centralization? Very low. So what's the takeaway? In the era of legal classification, decentralization isn't just a technical goal, it's a strategic requirement. And for some blockchains, it's a race against time. Earlier, I mentioned that blockchains and distributed ledgers can exist without cryptocurrencies. But cryptocurrencies, especially those with real utility, can significantly strengthen the networks they're part of. And that's exactly what token utility means. Can you stake tokens to secure the network and earn rewards? Are tokens required to pay transaction fees or execute smart contracts? Does holding the token give you a voice in governance decisions? These are not minor details. They're what drive consistent, long-term demand. Right now, crypto valuations remain largely speculative, but speculation doesn't sustain price in the long run. As blockchain technology moves into genuine adoption, utility is what will separate valuable tokens from merely speculative ones. Look at this table. Tokens like Algorand, Ethereum, or Chainlink score highly. They're integrated deeply into their platforms, so increasing adoption translates directly into token demand. Tokens with lower utility scores offer fewer reasons for long-term adoption. When large institutions and everyday users start relying heavily on blockchain, tokens with strong utility will have consistent, built-in demand, directly supporting their price. Simply put, utility is negligible in the short term, but it becomes everything once blockchain achieves widespread adoption. At this point, we've reviewed the technological strengths and the regulatory landscape. The question that remains is, does this translate into price growth potential? Consider this simple comparison. Ethereum, with a market cap of around $457 billion, sets our benchmark. Algorand, on the other hand, is valued at roughly $2.3 billion. For Algorand to match Ethereum's current valuation, its price would need to rise by about 200 times. That's around 20,000%. Yes, achieving this would be challenging, but history shows it's not impossible. Ethereum itself has experienced such exponential runs twice, and Solana accomplished a similar feat in less than a year. But even if we take a conservative stance, say, achieving just 10% of Ethereum's current valuation, Algorand could still experience a 20-fold increase. And even then, Algorand's valuation would remain 10 times smaller than Ethereum's. This highlights a crucial factor for price appreciation. Market cap matters. Ethereum would need an additional $457 billion just to double. Smaller market cap assets can see substantial percentage growth with significantly less capital inflow. I'm deliberately avoiding detailed technical analysis in this episode. While I personally use chart patterns to assess whether an asset is in accumulation or distribution phases, that method is subjective. And today, I want to remain as objective as possible. If you're interested in the mechanics behind price movements, I highly recommend my series, What Moves the Price, on this channel. And remember, nothing I'm saying here is financial advice. My goal is educational, and I'm simply sharing my thought process. We've covered technology, regulation, decentralization, utility, and market cap, but there's a deeper pattern. It's the law that finally told us which distributed ledgers are built to win. For the first time in crypto history, regulators are favoring quality, favoring decentralization, transparency, and real-world utility. The age of Luna-style speculation is ending. The era of rule of law and real adoption is beginning. And in that new era, tokens that meet these standards, while still being small enough to grow, might be the biggest winners of all. Thank you for watching.